Hi guys, so welcome to my YouTube channel. So today we solve the problem of common three sorted array. I will explain you the all approaches. There is 3 and 4 approaches if you have to learn and if you have to see this problem. The problem says that given a 3 sorted array, non-decreasing order, return all the common element in the non-decreasing order across all these arrays. If there is no such elements, return an empty array. The problem says that like you have 3 sorted non-decreasing order. In that all arrays, in all 3 sorted arrays, you have to find the common element in these all in this 3 array. You just like think like we have the 3 array, and in that array I just have to return which is common in all the third array 3 array. Like here is the common is like 1 there is not 1, 5 there is not 5, 10 there is not 10, 20 there is 20, there is 20, 1 is now 14 there is not 14, not 14, 18 there is 18 and there is 18. Yeah, so 20 and 18 are the answer. This is our problem, and this is the problem says that now in that there is 1 1 1 no, 2 2 2 no, 3 3 3 no, 4 4 no, 5 5 5 no. So this is the empty array, right? So this is the problem. Now just think, and also one more thing, that this is the edge case. What you have to ignore the duplicate, right? If you have the like 40 and 42 times the 40, then you just have to return the only for one time of the 40. So that is the problem. So in that problem, without further delay, we just explain the brute force approach, right? What you can do in the brute force approach. For every element in the array, in the first array, check whether it exists in the second array and the third array or not. Since arrays are sorted, we can search linearly or use binary search, but pure brute force means checking every element manually, right? So what is the logic behind this? For every element a of I, search search it in B, search it in C. If found in both, add to the answer, otherwise not, and avoid duplicating, right? So if you say, then I will write the code of, right, brute force approach. So the simple vector int answer, right, uh, answer, and then one loop for int I is equal to 0 to I greater than is equal to a dot size and I plus plus, right? Now int x is equal to a of I, right, and bool found in b is equal to false, and bool found in c is equal to false, right? Now for int j is equal to 0, j then is equal to b dot size and j plus plus. If b of j is equal to x, then found in b in b is equal to true, otherwise break, right? Now for one more loop, int k is equal to 0, j हो गया, I हो गया, अब k is equal to 0. now k greater than is equal to c dot size and k plus plus. Now if c of k is equal to x, which means found in c is equal to true, otherwise if found in b and then found in c, if answer dot empty and then answer dot back is not equal to x, answer dot whose back of x, and then return answer. Like this is the previous approach. I just see there is an error. Yeah, error is I and B, invalid I and B, where you can okay, I just always to use this, and I always to use this. So then which line? 24th. Oh sorry, this is okay. Now see, yes, pass. I think not pass because it will show the TLE, where that is the brute force approach. And time complexity of order of n into, you see there is n into m plus n into p, that is the use time complexity. This is not good for the constraints up to the 10 to the power 5, and the space is order of 1, absolutely. So here I just write the TC is order of n into m plus n into p, right? This is, and make sure it will not pass the test cases, all the test cases. See what happened, it will doing here till I just understand the better approach using hashing. Why? Because you see in that I just count the frequencies, and in that frequency we just found is possible to store in all three array. If yes, then return the same array, otherwise not. So using the hashing we can store element of all arrays in sets, right? Then check which element are present in all three sets, then check which elements are present in the all three sets, right? And then because we need to ignore duplicate set or ignored or unordered set naturally helps. So what is the logic behind this? The logic behind this: store all unique element of in a set S1, store all unique value of B in a set S2, all store all unique element in of C in set S3, traverse one set and check if the element exists in the other two sets, sort the result because output should be non-decreasing order. Right? This is now I think it will take a lot of time. For that reason it will not submit it and not pass all test cases. But yes, I can try one more time, just to wait it will pass on. Yeah, so in that optimal approach there is a two approach. One is the linearly, second is a binary. Why? I know the data is sorted order, so if the array is sorted order, then what which of the algorithm we can use? Always to the sorted, that is binary search, right? So that means better approach we can write for the two different approaches. One is linear approaches and second is the binary approaches. So I think it will, yeah, too much time. Okay, that it will take a too much time. So okay, fine, I know why you are taking too much time. So I write the which one? I just write the better approach using the linearly search, using a set right int s1 of a dot begin to a dot int, right? Now set int s2 of b dot begin to b dot int, right? Now set int s3 to c dot begin to c dot int, right? This is now just vector answer. Now just for int x2 s1, and then if s2 dot find of x, like I just compare from the s1 to present or not. So if x is if x1 is not equal to s2 dot int and s3 dot find x is not equal to s3 dot int. So here answer dot push back of x and then return answer, right? Now check this will pass or not. Yeah, in that a dot begins a dot int. Oh, the problem is set. Like we have the s1 that a dot, oh sorry, this is the not comma, my bad. Now code hyper speed, your code is home scratch almost done. Why it will take a lot of time, I don't know why this it will slow and why this that much slow. Just see what happening there. So and after that you just try yourself for the write the code in the binary search. I will write directly in the optimal approach. Like what we can do in the optimal approach, we just do a thing like, since all three arrays are sorted, we can use three pointers. Yes, if all three are equal, that element is common. Otherwise, move the pointer which has the smallest value. Correct? Why? Because the smallest value can never match the bigger value later unless it moves forward. Correct? So this is, I just use the three three pointer approach. The server is too much busy. Why you are too much busy? Mm, oh, sorry, this is the vector, not waiter. Okay, so this is, yeah, pass and try to submit. Submit or not? Why you are taking this much time again and again? So in that, the time complexity is simple. Uh, in that, there is a, you just think like time complexity order of n log n plus m log n plus p log p. This is right. Now I just add the optimal approach. In the optimal approach, the time complexity is simple. Uh, what is three pointer approach? So order of n. So why it will not pass all the test cases? I don't know why this will. I think that is the problem of server. Definitely, this is the problem of server. Okay. Yeah. So it will run, guys. You can see this better approach will run. Now I just come on the optimal approach using the three pointer approach, right? So write the only three pointer approach which is left here to the optimals, right? So start like a int I is equal to 0, j is equal to 0 and k is equal to 0. Now vector int answer, right? Now while I greater than of a dot size and j greater than of b dot size and c greater than is equal to a k greater than is equal to c dot size, right? Now we can do int x is equal to a of I, int y is equal to b of j. Now int z is equal to c of k. Now if x is equal to y and y is equal to z, then if answer dot empty and answer dot end answer dot back is not equal to x, right, then answer dot pushback of x, right, then I plus plus j plus plus k plus plus, right. Now else int minimum value is equal to mean of x, y and z, right. Here if x is equal to minimum value I plus plus, if y is equal to minimum value of j plus plus, and if z is equal to minimum value then k plus plus, then return answer, right. Now we check here pass. Now pass the process, yes, it will pass the process. So in that, this is the optimal approach. So thank you for staying till the end, and please like and subscribe my channel. Thank you so much.